That's suspicious.
So the working of jet engine is all about producing a high-speed jet at the exit. The higher the speed of the jet, the greater the thrust force. The thrust force makes an aircraft move forward. Such high-speed exhaust is achieved by a combination of techniques. If you can heat the incoming air to a high temperature, it will expand tremendously and will create the high-velocity jet. For this purpose, a combustion chamber is used. An atomized form of the fuel is burnt in the combustion chamber. Effective combustion requires air to be at moderately high temperature and pressure. To bring the air to this condition, a set of compressor stages are used. The rotating blades of the compressor add energy to the fluid and its temperature and pressure rise to a level suitable to sustain combustion. The compressor receives the energy for the rotation from a turbine, which is placed right after the combustion chamber. The compressor and turbine are attached to the same shaft. The high-energy fluid that leaves the chamber makes the turbine blades turn. You can see that the turbine blades have a special airfoil shape, which creates lift force and make them turn. As the turbine absorbs energy from the fluid, its pressure drops. Through these steps, we have achieved our objective, a really hot and high-speed air emitted from the exit of the engine.
To prove that an airplane engine is safe and reliable, it has to be put through a series of tests. One of the tests includes firing water in the engine at high pressure, and another includes firing dead birds straight into the engine. Firing birds into the engine! And we'll explain why and how all these tests occur. During these tests, a stream of water is forced into running engines, firing around 800 gallons of water per minute straight into the engine. These tests are done to confirm that the engines are powerful enough to go through heavy rains and even the hardest of storms without having the engines fail. If the engine meets all the safety parameters, the water is expected to come out without damaging the engine or its operation. If all this goes as planned, the engine has passed the water test. When the weather is colder and the temperatures get lower, we have icy conditions that can further damage the engine and cause a terrible accident. These conditions are particularly tricky and require different types of ice particles to test the engine. Huge balls of ice are thrown into the engine to know if it can withstand them and how quickly it can recover without a lot of damage done. They also do the hot and cold tests, which are done to check if engines can work properly under extremely high and extremely low temperatures and at high altitude.
This accident video illustrates the perils that the deck crews face. When a crewman forgets to duck as he passes in front of the jet's engine, the power is enough to suck him into the intake. Miraculously, the crew member is pulled free and survives.
Miraculously, the crew member is pulled free and survives.
I previously built an engine that ran purely on compressed air. Inside, it uses a diaphragm to create an airtight seal against a piston, which greatly increases its efficiency, and I ended that video claiming that it was perfect for a model aircraft. If only... 3, 2, 1. I would say that's a success.
There it is.
Here it is.
Made ready.
Wow. Straight through. Straight through all of them. Straight every time.
After putting the speed of the bullet up on screen, you can now see that there are several panes of glass that the bullet doesn't actually touch. It seems as though
Then you get on the plane. Pilot, of course, always has to come on the PA system. This guy's so excited about being a pilot, he can't even stand himself. Well, I'm going to take it up to about 20,000. Then I'm going to make a left by Pittsburgh. Then I'm going to make a right by Chicago. Then I'm going to bring it down to 15,000. You know, it's giving you the whole route, all his moves. We're in the back going, yeah, fine, that's all. You know, just do whatever the hell you got to do. I don't know. Just end up where it says on the ticket, really, is our only concern. Do I bother him with what I'm doing, knocking on the cockpit door? I'm having the peanuts now.
Captain Sonia Laxo, a 23-year veteran at American Airlines. She, like other pilots, uses autopilot on every flight. And while it controls
the ailerons, the flaperons, and the spoilers on both wings, the elevator on the tail, and as well as the rudder. The main components of the autopilot system are the autopilot flight director system and the auto throttle system, actually controlled by what we call the mode control panel and the flight management computer, the FMC, which we most of the time just call it the box.
the mode control panel and the box. Those are both controlled by the pilots on the flight deck.
By using the mode control panel, the flight management computer, we command that autopilot flight director system and the auto throttle system to perform the climbs, the cruise, the descents, the approach, and in certain circumstances, the actual landing itself.
But the autopilot system extends outside the cockpit.
The autopilot relies on a series of sensors all around the aircraft collecting data.
GPS information, as well as data on airspeed and altitude, are fed back to the computers on board, which use the information to determine if a plane is veering from its preset route.
The computers are always running. I mean, they're very fast speed, so anytime there's any little discrepancy, it's going to make an adjustment to keep that aircraft on that flight profile.
Certain autopilot systems prevent input from pilots that would, for example, force the plane to turn too sharply or raise the nose at too steep an angle.
Initially, at the gate, we download the route into the FMC, the box, so then the autopilot knows what it needs to be following as per the route, and also performance, airspeed, fuel consumption.
Yet, the autopilots control the takeoff, but they must engage the autopilot above 28,000 feet due to vertical separation requirements, though most pilots press the button sooner.
Name one thing in your industry or profession that the general public would be shocked to know about.
I'm an air traffic controller, and there are about 139 federal standalone air traffic control towers in the United States. I work at one. And every night, 84 of those, about 60%, shut down. And all the controllers go home, and there's nobody there to work traffic, and then they come back in the morning and reopen. And during those hours, when the control tower is closed, it's the pilot's responsibility to talk to other pilots and make sure that they're not going to hit each other.
That's suspicious. That's weird.